The amendments to the stormwater management rules, which are found in the New Jersey Administrative Code in Title VII, Chapter 8, and the Flood Hazard Area Control Act, or VACA rules that are found at NJAC 7:13, were adopted and published in the New Jersey Register on July 17th of 2023. The amendments address one of the major threats climate change presents, and that is increased volume and intensity of rainfall events, and the attendant effect of the additional runoff on stormwater management systems and flood elevations in riverine areas. So first, this presentation will provide some of the history leading to the amendments to the stormwater management rules. I'll then cover the two definitions that have been added to the rules, and after that, I'll go over the applicability to major development and discuss the legacy provisions, which are those projects subject to the prior rules under certain conditions. The legacy provisions will be followed by the change to the allowable calculation methods. And after that, there will be a longer discussion of the multipliers that are to be applied to modify the published rainfall data and how those multipliers are used in the calculations for stormwater recharge and stormwater runoff quantity control. After that will be some examples. And I'll also briefly review the other updates that were made to the BMP manual, the FAQs published online, and the Municipal Stormwater Control Ordinance, which we abbreviate as SCO. And lastly, we'll have a Q&A session before wrapping up. Okay, so don't leave the meeting until I make the announcement to dismiss you so that you are fully complete for this permit requirement. All right, so now for that quick history lesson on what led to the rule amendments and an overview of the studies involved. Executive Order 100 was signed by Governor Murphy on January 27th of 2020. This required that the DEP shall, within 2 years of the date of this order and consistent with applicable law, adopt Protecting Against Climate Threats, abbreviated PACT, regulations. Furthermore, it required the DEP integrate climate change considerations such as sea level rise into its regulatory and permitting programs, including, but not limited to, land use permitting, water supply, stormwater and wastewater permitting, and planning, air quality, and solid waste and site remediation permitting. Subsequently, an Administrative Order 2020-01 was signed by then Commissioner McCabe to integrate climate change considerations and so forth into the DEP's regulatory and permitting programs. So in accordance with the executive order, the department conducted research and underwent several stakeholder meetings beginning in 2019, first as part of the PACT rules, and then again independently in October of 2022. The department released a New Jersey scientific report on climate change in 2020 and reports on rainfall studies in 2021. All of these were in preparation to address the impacts of climate change, which then led to the proposal on December 5th of 2022 and adoption on July 17th of last year of the Inland Flood Protection Rule. The reasoning behind the rule amendments is based on the scientific studies showing that data used for the design of stormwater infrastructure is outdated. It no longer reflects what is happening in our state, so much so that in November of 2021, the Northeast Regional Climate Center, which is a partner with the National Oceanic and Atmospheric Association.
Okay, so you just sent another email, hold on.
Abbreviated as NOAA, and the DEP released studies showing that the 2, 10, and 100-year storms have all experienced increases in rainfall depths since 1999. Furthermore, reasonable predictions based on this information show that this will only worsen over the coming decades. The areas that have the darkest blue shading in this graphic are anticipated to have 100-year storms that will increase between 141 and 150% by the end of the century. More rain means more runoff, so that means larger discharges, and we will also see more flooding as a consequence. So additionally, global warming increases both the energy in the atmosphere and the potential for more intense storm events. The science predicts these storms will occur more frequently and at higher intensities than those of the 20th century. So I'll cover more of this shortly. So we've experienced quite a number of major flood events since the year 2000, some of which are noted on this slide. All right, so in many locations, stormwater runoff is often discharged off-site, and with the increasing intensity and rainfall depth, this will stress our infrastructure, such as bridges, roadways, and stormwater management systems, and will create further problems down gradient of those discharge points. So this in turn increases risks to the inhabitants and properties. So keep in mind, New Jersey is the most densely populated state, and most of the population centers are in the floodplain. So adding climate change on top of worsening flooding is just going to compound the issue and make things unsustainable. NOAA's rainfall precipitation and intensity data that is published in Atlas 14, Volume 1, or on NOAA's Precipitation Frequency Data Server, PFDS, is essential to stormwater management designs. However, the precipitation depths and intensities were based on data collected from weather stations ending in 1999. That means the design based on that information doesn't really reflect the precipitation we are experiencing today. Add to that runoff from older sites where there was no stormwater management and the impacts worsen. That could potentially wipe out infrastructure and put people in danger. So climate change will continue to bring more intensive rain in the future. A stormwater best management practice, or a BMP as we abbreviate them, has a long service life, and BMPs designed in accordance with outdated rainfall data will become insufficient to handle the increasing precipitation depths and intensities. Therefore, there's a real need to anticipate the increase of precipitation depths in anticipation of the effect of climate change and use the predicted precipitation depths to design stormwater BMPs. The adopted rule amendments are what is required to address these impacts. So the stormwater management rules at NJAC 7:8 were amended to address the rule of climate change in BMP design. So first, I'm going to give you a guide as to which subsections of the rule were amended. All right, so we'll start with subchapter 1 of the rules, and I've underlined the subsections where the rules were amended. So that's 1.2 and 1.6. All right, and I'll discuss those changes momentarily. On this slide, you see the layout for subchapter 5 in the rules, and within this subchapter, the rule adoption amended only the underlined sections, namely 5.4, 5.6, and 5.7. And I'll discuss those changes after I do the ones for subchapter 1. So in the amended rules, 2 definitions have been added regarding public transportation projects that are subject to the rules in effect prior to this rule adoption, and that will be dependent upon when.
Okay, I turned the wrong thing on.
Okay.
All right, thank you.
I close the door.
Sure.
That will be dependent upon when the public transportation projects achieved a certain status. So a public roadway or railroad means a pathway for use by motor vehicles or trains that is intended for public use and is constructed by or on behalf of a public transportation entity. A public roadway or railroad does not include a roadway or railroad constructed as part of a private development, regardless of whether the roadway or railroad is ultimately to be dedicated to and or maintained by a governmental entity. Now, a public transportation entity means a federal, state, county, or municipal government, an independent state authority, or a statutorily authorized public-private partnership program pursuant to public laws of 2018, Chapter 90, as shown on the slide, that performs a public roadway or railroad project that includes new construction, expansion, reconstruction, or improvement of a public roadway or railroad. So note that a public transportation entity includes municipalities and counties that perform public roadway or railroad projects, but does not include the roadway within a private development, even if it's dedicated to the municipalities or counties, or is to be maintained by those municipalities or counties. Next is the applicability section of the amended rules. So first of all, the applicability section indicates that all major development that doesn't fall under item B is subject to the rule amendments. So going forward, we will refer to item 1.6B as the legacy provision, okay? Secondly, a major development project that does not need those permits listed in section 1.6C, which are the flood hazard area, the freshwater wetlands, a CAFRA, a waterfront development, or a highlands permit from the department, and has submitted an application for the approvals listed in the Romanets 1 through 5 that are on this slide prior to July 17th of last year, will not be subject to this rule adoption. A complete application means that the application submitted to the municipality has all of the required documents specified in the municipality's ordinance, and the municipality's reviewer considers the application complete for the review of the stormwater management design. So take note that the application and all accompanying documents shall include the documents for stormwater management. So if the application submitted to the municipality for those approvals did not include the required design documents for stormwater management, the legacy provision here will not be applicable. Item 2 establishes the time frame for projects subject to the rules in effect on March 1st of 2021. Again, providing it included all of the required materials I just discussed. Similarly, the same goes for item 3, except the rules are those in effect on March 2nd of 2021, and projects are also subject to the same conditions regarding the items submitted. Okay, now item 4 is for projects submitted to the department. If a major development project needs a flood hazard area, a freshwater wetlands, a CAFRA, a waterfront development, or a highlands permit, and those permit approvals need a stormwater management review component, is technically complete and has been submitted prior to July 17th of last year, it's subject to the rules either in effect on March 1st of 2021 or the rules that were in effect from March 2nd of 2021 through July 16th of 2023, depending on when it was submitted, and provided everything required by the department's rules for those permits, plus the application form, were submitted prior to July 17th of 2023. Okay, and remember, technically complete means each item included in an application provides sufficient information for the department to declare the application complete for review, public comment, or public hearing. Okay, so these are those department permits I mentioned earlier, along with where they're found in the New Jersey statutes. Okay, I'm not going to read them. And we're just going to move on. All right. Exemptions expire with the expiration, termination, or other loss of duration or effect of either the qualifying local approval or the department permit, whichever comes first. The expiration of local approvals under B1 is governed by local ordinance. Now, in the event that there are multiple qualifying department permits under item C that was on the previous slide, the expiration date is governed by that permit which expires last, provided that the permit is still in effect. So once the exemption expires, the major development shall be subject to all requirements of this chapter upon reapplication for that permit and all subsequent permits or local approvals under the municipal land use law. Okay, now there's one more citation for limits on these exemptions. All right, and this part's really important. So the aforementioned exemption is limited to the land area and the scope of the project addressed by the qualifying applications or the subsequent approvals. Okay, the review agency will consider the impacts from any revision, including but not limited to the items that are listed here on this slide, and they may deem the exemption void if the revisions do not have a de minimis impact. Okay, there's also an additional legacy provision that exists for certain public roadway and railroad projects, and that is found in NJAC 7:8 under 1.6F. Public transportation entities must demonstrate that the project has determined a preferred alternative or has reached an equivalent milestone prior to the rule adoption. And the logic is just that these projects have already undergone a significant level of planning and design such that revising the project now to meet the new rules would be a waste of public funds. Okay, so let's do some examples. There's 4 of them to help clarify the applicability portion of the rule adoption. So 2 are for where department permit is required. So for example, 1, a non-residential major development submits an application for the department's flood hazard control area Act permit with a stormwater review component on August 1st of 2023, and it is deemed technically complete. The non-residential major development also submits an application to the township for a preliminary site plan approval on August 1st of 2023, but the township stormwater control ordinance was still in alignment with the rules in effect prior to July 17th of 2023. So what rules and SCO are applicable to this particular project? Department will review the stormwater component of the application under the stormwater management rules that were adopted on July 17th of 2023. So the non-residential major development shall have its stormwater management design in accordance with the amended adopted rules. However, the township will review the stormwater management under its SCO pursuant to the prior rules. Since the design complying with the amended rules as adopted is supposed to be more comprehensive and has a higher capacity than the design under the prior rules. So the design under the adopted rules should be able to pass the SCO pursuant to the prior rules. For the second example, we have a non-residential major development submitting an application for a department's flood hazard permit with a stormwater review component on June 1st of 2023, and of course it was deemed technically complete. The non-residential major development also submitted an application to the township for a preliminary site plan approval on December 1st of 2023. Now, by then, the township's SCO had been amended to be consistent with the amended rules adopted on July 17th. All right, and so what rules on SCO are applicable to this particular project? Well, the department will review the stormwater component of the application under the stormwater management rules on effect on July 16th, the prior rules, but the non-residential major development will need to redesign its stormwater management to comply with the township's SCO pursuant to the adopted rules. Receipt of the department's approval on the stormwater management design does not necessarily secure the township's approval. The township's reviewer shall apply the township's SCO pursuant to the adopted rules when reviewing the stormwater management of this particular project. All right, so now for 2 examples where a department permit is not needed. Okay, we have a non-residential major development submitting an application to the township for preliminary site plan approval on December 1st of 2023, but the township's SCO was still in alignment with the rules in effect prior to July 17th of 2023. The project will not require any of the department permits that are in the list published in subsection 1.6C. So is the project subject to the amended stormwater management rules? Okay, so the township will review the stormwater management design under its SCO pursuant to the prior rules, provided the submittal included all of the required documents prior to the township amending its SCO pursuant to the July 17, 2023 amendments to NJAC 7:8. So pursuant to the requirements of the MS4 permit, the township must revise its SCO to align with the amended rules and have it be in effect within 1 year of the rule adoption. That's next week. And for our last example, we have another non-residential major development that submitted an application to the township for preliminary site plan approval on December 1st of 2023. And by this time, the township's SCO had been amended to be consistent with the rules adopted on July 17 of 2023. So no permit is required from the department. So is the project subject to the amended stormwater management rules? All right, yes, the development will need to redesign its stormwater management to comply with the township's SCO pursuant to the adopted rules. The township's reviewer shall apply the township's SCO pursuant to the adopted rules when reviewing the stormwater management of this non-residential major development. So reviewers need to be aware of the status of the municipal SCO with regard to the rule amendments. All right, next up, we're going to look at the amendments to subchapter 5, which is the design and performance standards for stormwater management. All right, going forward, the slides that you see with the red stripe on the left all pertain to subchapter 5 of the stormwater management rules. Now, there's no changes to subsections 5.1, which is scope, 5.2, stormwater management measures for major development, 5.3, green infrastructures, 5.5, water quality, 5.8, maintenance, or 5.9, technical sources. But I'm going to handle the remainder of the subchapters out of order, starting with 5.7, computational methods, as this impacts the remaining subsections. So there is a change in the allowable computation methods, namely only the NRCS methodology is found in the adopted rules. So take note that the NRCS methodology must be used when calculating the water quality design storm. So throughout the remainder of this presentation, I'm going to do my best to give you the page citations from the BMP manual. And this information is included under item 13 on page 32 of chapter 5 in the BMP manual. All right, so you may also refer to the National Engineering Handbook, which is available from at the link that's shown on the slide. All right, now you may no longer use the rational method nor the modified rational method to calculate stormwater runoff, whether for groundwater recharge, stormwater runoff quantity control, or water quality. The rationales and the justifications to eliminate the rational method and the modified rational method are addressed in the rule adoption notice that's available on the department's website. We're not going to repeat that stuff here. So just a note, the rational method is still applicable for storm sewer or drainage system design pursuant to the residential site improvement standards found in NJAC 7:21 in subchapter 7.2 under item C5. So when using the NRCS methodology, slope, cover condition, and precipitation depths are the parameters we need to know to perform the calculations. So we're going to talk about the requirements for the precipitation depths that we have to use in the calculations. The rule amendments require calculations be based on 2 different precipitation depths calculated by applying multipliers to the outdated rainfall data. The first set of precipitation depths to be used will adjust the 1999 rainfall data to the year 2019 for the 2, 10, and 100-year design storms all right, which is what the amendments mean whenever the words current design storms are specified, all right. To the right is a reprint of table 5-5 from the rules. To denote the adjustment of rainfall data to 2019, the precipitation depth we will use for the 2-year storm for a project, say in Warren County, is 102% of the depth listed on the NOAA PDF server for the 2-year storm. For the 100-year storm for a project in the same part of Warren County, or Warren County in general, the rainfall depth is adjusted to 115% of the 100-year rainfall depth found on the NOAA PDF server. So that's what these are, okay? The first example presented later on today will illustrate the calculation of the current precipitation rainfall depth for a site. And if you aren't familiar with using the NOAA PDF server, start on page 12 of the revised chapter 5 in the BMP manual, and that is was published in July of 2023. All right, now for a site in more than one county, you're going to multiply the rainfall depth from the first area by the county-specific current precipitation adjustment factor for the design storm specified, and then multiply that product by the percentage of the total site area lying in the first county. You use the same method for the second area using the current precipitation adjustment factor for the second county for the same year design storm, and then multiply that product by the percentage of the total site area that's located in the second county. Lastly, you sum the two to get the current adjusted total rainfall depth for that design storm. And chapter 5 in the BMP manual has an example. It has the number B1, and it is found on page 18, and it depicts a site situated in 2 counties. Now, as an alternative, you can use the county 24-hour rainfall data from the NRCS, but you would then also apply the current precipitation adjustment factors from table 5-5 in the rules. Okay, the county-specific 24-hour rainfall frequency data published by the NRCS in the 2012 Engineering Field Handbook is reprinted as table 5-1 on page 15 of chapter 5 in the BMP manual. Okay, now there's a second multiplier required in the rule amendments. You're going to apply the future precipitation change factors to the published NOAA rainfall data to allow us to look ahead to the period from the year 2050 through 2099 to address the future impacts of climate change. So when the rule amendments call for something as the projected 2, 10, or 100-year design storm, that's the calculation that I'm talking about, okay? To the right is a reprint of table 5-6 from the rules. So this means that the precipitation depth we should use for the projected 2-year storm for a project in Warren County is 120% of the depth listed on the NOAA PDF server for the 2-year storm. For the projected 100-year storm in Warren County, the rainfall depth is adjusted to 137% of the 100-year rainfall depth found on the NOAA PDF server. So Warren County, 2-year storm, 100-year storm, future precipitation change factors. And again, for a site that's located in more than one county, we're going to use the same method from the bottom of the previous slide, but in this case, be sure to use the future projected change factors. You multiply the rainfall depth from the first area by the county-specific future precipitation change factor for the design storm, and then multiply that product by the percentage of the total area that is lying in the first county. Do the same thing for the second area using the future precipitation change factor for the second county for the same design storm, and then sum these products together to get the future projected total rainfall depth for that design storm. All right, so I'll have some examples in just a moment. So one other calculation we have to talk about is time of concentration. All right, the equation itself uses the rainfall depth resulting from the 2-year storm event. All right, so Although how to calculate the travel time of runoff in sheet flow is not explicitly stated in the rules, it's because the rules require using the current and the projected 2, 10, and 100-year storm events in the stormwater calculations. The 2-year storm event used in the calculation of travel time for sheet flow also uses the current and projected 2-year storm events respectively. So time of concentration for the current storms will use the current rainfall data. Okay, you're multiplying the rainfall depth from NOAA for the 2-year storm by the 2-year current precipitation adjustment factor. But for projected storms, you're going to multiply the NOAA rainfall depth for the 2-year storm by the future precipitation change factor for the 2-year storm. So if you're dealing with very small areas, there really won't be much difference, but there definitely will be for larger areas. Now, one other thing I want to mention is that the rainfall depth of the 2-year storm, P sub 2, that is used in the time of concentration for the water quality design storm is based on using the projected 2-year storm event. All right, it's a lot of information. You're going to want to earmark page 25 of chapter 5 in the B&P manual until you get this down. Okay. All right, so now that I've explained what the rules mean by a current or a projected design storm, we're going to go back to subchapter 5.4 in the rules. So for groundwater recharge, the rules allow you the option pursuant to 7:8-5.4B1 little I to address the loss of recharge on an annual basis, and that is done through the use of the groundwater recharge spreadsheet. Nothing changed for this option under the amended rules. Okay. However, if you're going to infiltrate the difference between the pre and post-construction runoff volumes, you must do so as required under the second option shown here using the projected 2-year design storm. So remember, the projected 2-year storm uses the future precipitation change factors found in table 5-6 and of course you go to the column for the 2-year storm. So the design is going to look at what would happen if nothing on the site changed versus what site changes are proposed and their impacts at 2019 and in the future. All right, so you may find that examples 5-6, 5-7, and 5-8 in chapter 5 of the B&P manual are helpful on this subject. And also I want you to know that chapter 6 of the B&P manual has been updated to match the rule adoption. All right, so now for the stormwater runoff quantity standards, which are found under subsection 5.6 of the rules. So there's 3 options from which to select in order to demonstrate compliance with the requirement to control stormwater runoff quantity impacts. So under the bullet is the rule text for the first option to demonstrate compliance with the stormwater runoff quantity standards. Note that the bold or yellow text is the portion of the rule that has been amended in the adopted rules. So you're going to recall that 5.7C was covered on slide 25 and 5.D was covered on slide 26 respectively, okay? So 2 previous slides. The bolded text is going to be discussed after we look at the other options for demonstrating stormwater runoff quantity control compliance. All right, so this is the rule text for the second option to demonstrate compliance with the stormwater runoff quantity standards, okay? As on the previous slide, the bold or yellow text is the portion of the rule that has been amended in the rule adoption. So, all right. And this is the rule text for the third option to demonstrate compliance with the stormwater runoff quantity standards. Once more, the bold or yellow text is what has been changed in the rule adoption. Okay, so regardless of which option is selected, the quantity control calculations that are required will have to include an analysis of the runoff volumes produced for both the current and the projected design storms. So you will review the pre-construction, aka existing conditions, and what is proposed using the rainfall data to which the current precipitation adjustment factors are applied to do your comparison using the numbers that reflect what was precipitating in 2019. You also have to review the pre-construction or existing conditions and what's proposed using the rainfall data to which the future precipitation change factors are applied to do your comparison using the numbers that reflect what will be happening from 2050 to 2099. That way, your review checks the design's work for what's currently precipitating and what we can expect will precipitate due to climate change. So if you recall, I covered time of concentration calculations on slide 27, but they come into play here. So what I'm going to caution you is that if you're using modeling software to design or to review the accuracy of said designs, you may want to make sure or to create a model for the projected storms that is separate from the current storms because of the different P sub 2s, okay, and for the different rainfall depths. All right, you may also want to look at page 84 of chapter 5 in the BMP manual, which summarizes the updated modeling guidance. Okay, so it's existing for, the current versus proposed, and existing for the projected versus the proposed for the projected. Okay, so you're not mixing current and projected, you're keeping them straight, and you just have a lot more calculations to check. Okay, we're going to pause for a second. You're going to need to remember the code that is shown on this slide for when I tell you it's time to take attendance. And I said this at the beginning, but I'm going to repeat it for those who joined us late. You're going to need to make sure you enter this code into the survey when I tell you it is time to take the survey via the SurveyMonkey QR code or using the URL we provide later on if you want to be marked complete. Your other option will be to email us with this code during the exact time period that I specify. Okay, you can't do it now. You'll have to wait. Okay, but write this code now and I'm going to remove it or it'll be removed from the chat momentarily. Don't retype it into the chat and don't share it with other people. Retyping or sharing the code with others will result in a forfeiture of your attendance. So with that being said, let's move on to the examples. All right, I have 5 examples. The first is applying the current precipitation adjustment factors to a site located in just one county. The second example is for a site partly in one county and partly in another. The third example is a comparison of the hydrographs from the pre and post development conditions for the projected and current storms where impervious cover is reduced in the proposed design. The fourth example shows a design using a small scale BMP, how it will meet the groundwater recharge requirement. And the fifth is sizing an MTD using the NRCS methodology, since we used to allow you to use the rational method and you can no longer use the rational method. Okay, so for the first example, we're going to apply the current precipitation adjustment factors to the rainfall data for a site located at Trenton Station 2 on as shown on the NOAA NWS PFDS website. All right, so first we go to the website found at the URL I've shown on the slide, and in the data description section from the data type drop-down menu, you're going to make sure that precipitation depth rather than precipitation intensity is selected, all right, as shown on the left. All right, then for the time series type, you're going to make sure you pick partial duration from the drop-down menu. And then in step B, under the select location option, manually enter the location using one of the options offered on the screen, or use the map to locate the site, making sure you zoom in. All right, we're looking for Trenton Station 2 in this example. Next, you're going to scroll down the web page to the point precipitation frequency estimate section. You're going to left click on the PF tabular option. If it doesn't appear on the top of the other tabs, they'll be shaded in dark blue. All right, the data needed is found in the row labeled 24-hour. I know it's really tiny. All right, but the values in the columns for the 2, 10, and 100-year correspond to the rainfall depths generated by the 2, 10, and 100-year design storms, respectively, for this particular location. All right, and that's what's in the red boxes. Next, you're going to go to table 5-5 in the rules and look at the row for Mercer County, since that's where our site is located. Okay, to obtain the current precipitation depth for the 2-year design storm, multiply the NOAA precipitation depth for the 2-year design storm, which is 3.3, by the 2-year current precipitation adjustment factor of 1.01 to get the 2-year current rainfall depth of 3.36 inches, which is shown in the column on the right. And then you repeat the process for the 10 and 100-year design storms using the respective adjustment factor. So that's how you get a 10-year current rainfall depth of 5.09 inches and a 100-year current rainfall depth of 8.48 inches. And that's shown in the column farthest on the right in the table on the slide. So if you aren't familiar with using the NOAA PDF server, start on page 12 of the revised BMP manual in chapter 5. It was published in July of 2023. Okay, for the next example, when a site is situated in 2 counties, the method is to obtain the current adjusted rainfall depths for each of the 2 counties and then weight average them based on the area of the site in its respective county. So here the site is located on the county line shared by Middlesex and Mercer counties. 1/3 of the site is in Middlesex and the remaining 2/3 is in Mercer. So in step A, we obtain the NOAA data and the current precipitation change factors and calculate the rainfall depths for each of the design storms for each of the counties. Then, as we shown in the second table, we multiply the percentage of the project area within each county with the current precipitation for the respective county from step A, and then we sum the results for each of the design storms. So the final current precipitation depths are in the bottom row of the lower table. Okay, this example is going to provide a scenario showing non-compliance with the requirements when the proposed development reduces the regulated motor vehicle impervious surface and increases the slope of the surface. So often for redevelopment projects, a designer may choose the option at NJAC 7:8-5.6B1 to demonstrate compliance for quantity control that for stormwater leaving the site, post-construction runoff hydrographs for the current and projected 2, 10, and 100-year storm events as defined and determined pursuant to NJAC 7:8-5.7C and D respectively do not exceed at any point in time the pre-construction runoff hydrographs for the same storm events. Okay, so for a site located in Trenton, Mercer County, an approximately 2-acre paved parking lot is to be redeveloped as an office complex consisting of a new building, a parking lot, and some landscaping. The existing lot has a slope of 1%. The redeveloped site will be regraded to 5% slope for better drainage. The landscaped area will not receive runoff from the impervious surfaces. Okay. And we're going to assume in this case that HSGC soils are present. Okay, so here is our layout. And for brevity's sake, we're going to look at the projected 100-year design storm. Okay, so we have a summary in the table from our modeling software. All right, to correctly calculate the time of concentration, the first P sub 2 was calculated by multiplying the NOAA PFDS rainfall depth for the 2-year storm, that is 3.33 inches, with the future precipitation change factor of 1.16, and for this, P sub 2 is calculated to be 3.86 inches. So in the table is the summary information, and it looks like the results for the post-construction condition are less than the pre-construction values. So next, the modeling software is used to produce the hydrographs with the peak flow rates and time intervals, then exported as data for input into a spreadsheet to create a chart. All right, although it's not shown here, at first the hydrographs seem to demonstrate compliance, meaning the post-construction volume looks like it's less than that for the pre-construction condition, meaning that the post-construction hydrograph would be under the pre-construction hydrograph. However, when we take a close look at the hydrograph table data, this shows that it's not the case. Okay, a zoomed-in view of the pre- and post-condition hydrographs are shown on the slide. So even a reduction in impervious cover should be reviewed to check the adjustment or change factors have been correctly applied to the appropriate storm calculations, and then the data must be examined, all right, to confirm that there are no exceedances. The hydrographs can be, not altered, but shrunk down so that you can't see it. Look at the data. You would similarly inspect the data for other projected and all of the current design storms to look for other instances where the post-development hydrograph exceeds the pre-development hydrograph. All right, this example is actually in the B&P manual in chapter 5, and it starts on page 41. Okay, so there isn't an automatic meeting of the quantity control requirements. All right. Example 4, this one provides a scenario showing the groundwater recharge calculations. And for this, we've got a 2.5 acre wooded lot located in Somerset County. The latitude and the longitude of the site are 40.4573 degrees and -74.5309 degrees respectively. The proposed development consists of a 1 acre office building, a 1/2 acre parking lot, and a 1/2 acre lawn area, plus 1/2 an acre of existing woods that will remain undisturbed. We're going to design a stormwater management system to meet the stormwater management rules, and we are going to use HSGB soils. So here we're going to assume that a small-scale infiltration basin is to be designed to meet the design and performance standards for demonstrating compliance with the groundwater recharge requirement by infiltrating the increase in stormwater runoff from the pre-construction to post-construction for the projected 2-year storm. And we're going to calculate the volume of runoff to be recharged. So you're going to find this in the chapter 5 of the B&P manual, but the design is laid out to manage stormwater close to its source, and that example includes in detail the calculations. So if you want to see that, go to example 5-8, beginning on page 71. Okay, and then we're going to skip the parts of the design calculations because I just want to focus on the groundwater recharge requirement. So for this site, I've included the NOAA rainfall depth, the future precipitation change factor for Somerset County, and the depth of precipitation for the projected 2-year design storm. So with a precipitation depth of 3.93 inches, the projected 2-year storm will produce an increase in runoff volume for the post-construction condition, which is 17,886 cubic feet, as shown in the lower table. So to comply with the rule requirement, this is the target the design must achieve, provided it is designed in accordance with the rest of the information in the B&P manual. Okay. And example 5. So this one is sizing an MTD using the NRCS methodology. So if you recall, the rule amendments discontinue the use of the rational method and the modified rational method for stormwater calcs. And this example will walk you through what is now required. Okay, so we have a 1/4 acre site with a slope of 5% and it's 100% impervious, so our CN is 98. For this, the projected 2-year rainfall depth is 3.84 inches, and we need to know the hydraulically most distant point to the inlet of the MTD, and for this example, it's 110 feet. So, all right, when using the NRCS methodology, you're going to have to calculate the time of concentration, and we follow the method covered in example 5.1 of chapter 5 in the BMP manual. All right, and if you're in there, you just go to page 33. It's also the formula that was on slide 27. All right, now, as was stated earlier, we use P sub 2 for the projected 2-year storm in the TC calculations for the water quality design storm. But there really won't be much difference here if we mistakenly use P2 from the current 2-year storm, given that the drainage area is only a 1/4 acre. Okay, but do watch that for your larger areas. So then what we have to do is calculate the maximum sheet flow length using the formula for the McEwen-Speece limitation. And remember, that's found on page 24 of chapter 5 in the BMP manual. And for this, it's equal to 909 feet. However, the maximum sheet flow length should not exceed the McEwen-Speece limitation, or 100 feet, whichever is shorter. So that means we use 100 feet. Okay, so for our stated flow path length of 110 feet, that leaves only 10 feet of shallow concentrated flow. And for this, T sub C is calculated to be 0.8 minutes. Next, we also have to use the SCS standard dimensionless unit hydrograph with a shape factor of 484. And this is covered on page 27 of chapter 5 in the BMP manual. And with all of this together, the modeling software calculates the peak flow rate for the water quality design storm is 0.777 cubic feet per second. Now, the next step would be to determine the size of the MTD. And the selection of a model of a specific MTD listed on the department's MTD webpage is based on the maximum treatment flow rate for a hydrodynamic type MTD, or the maximum allowable drainage area evaluation method, and the MTFR evaluation method per the certification letter for a filtration type MTD. Look also at chapter 9.5 for your GI MTDs and for chapter 11.3 for MTDs that are not certified as green infrastructure for this particular calculation. Okay, so it's quick, but that's it for the examples today. All right, I want you to go through chapter 5 of the BMP manual for even more detailed examples, and you're free to contact us if there's something that isn't clear or could be improved. Okay. All right, now the BMP manual chapters, which have been updated to align with the rule adoption, are listed here. All right, we also recently updated chapter 12, but just take note that your handouts don't show this update. Okay, sorry about that. Additionally, we also updated the FAQs and they are overhauled to address the various issues. Okay, just look for the section on the rules. All right, since there's different subsections. All right. And then here are just some screenshots from the updated BMP manual webpage. Everything that has been updated to this rule adoption has been marked as updated, you know, kind of this kind of thing. See right here, updated. I think there might be some for chapter 12 showing that it was updated in March, okay? But we use the red text with the lovely asterisks to denote the updates, okay? And then, as I said, the FAQs have been expanded to address various issues, some of which may have even been mentioned on the earlier slides. And they're at the bottom of the webpage above the blue footer that we use now. All right, just look for the rule adoption date. And if you click on a question, it will expand to show you the answer. So just click on any of these and they'll expand. All right, now the updates to the SCO align with the rule adoption and can be downloaded in Word or even PDF formats. All right, and on the left is a screenshot from the updated webpage that shows all of the different items that are available. Where's my mouse? My mouse is not cooperating. All right, to download. There's even a clean copy, and there's a strike-through version that illustrates where text has been removed, and new text in that version also appears in red. And finally, there's a simplified version that cites subchapter and section numbers from the stormwater management rules instead of the full text to reduce or eliminate the need for the municipalities to revise their ordinance when the stormwater management rules are amended. The municipality has to comply with the applicable laws and procedures for the passage and adoption of ordinances pursuant to this simplified versions. Now, municipalities must amend their municipal stormwater control ordinance within 12 months of written notification by the department of the need for modification and update. That notification was sent on July 17th of 2023. And as I said before, we're getting pretty close to that 1-year deadline. Okay, so on the lower part of the slide is a summary of the updates that were made to the SCO to match the rule adoptions. And we also, of course, updated the hyperlinks throughout the document, and we generally cleaned up the appearance to make it more user-friendly. So we're not done yet, so don't leave, okay? Don't. All right, we're going to recap the rule adoption part of the presentation, all right? We had 2 definitions that have been added, and after that, I covered the applicability to major development and discussed the legacy provisions, which are those projects subject to the prior rules under certain conditions. And it's also important to remember that there was a change to the allowable calculation methods, which I covered. After that, we had a little bit longer discussion of the multipliers to be used to modify the NOAA's published rainfall data and how those multipliers are used in the calculation for groundwater recharge and stormwater runoff quantity control. Now, I hope you found the examples helpful, and there's more, as I said, in Chapter 5 of the B&P manual. And if you go to page 33 in Chapter 5, you will find a table listing all of the examples. And lastly, I also briefly touched on other updates made to other parts of the B&P manual, as well as the FAQs and the Municipal Stormwater Control Ordinance. Okay, so if you have questions, it's okay. You can reach us through this contact information, and we're not done, so don't leave. We will at some point make the video available for you to download for reference. You have the slides. But please continue to periodically check the website for updates to the B&P manual and the other stormwater related material.